questions or points to make? Yeah, in the back.
I just want to make a comment about the classification, the work that the community has been doing on classifying transients. We saw some great models that can identify supernovae, for example, or microlensing, even showing early detection capabilities. But we know that if you have enough quality data, it is not challenging to train a machine learning model to find what you're looking for. The big challenge is, can you reduce the number of false positives? So I've been thinking about this, particularly for the models that I train, is a lot of these times, these models that we train are very good at detecting a particular object of interest. We pay very careful attention and love to curating a training set that works great for finding that object. But I mean, it's challenging to put the same amount of effort into the other false positives that we may or may not want to include. So when we tap into the alert stream, I think it would be best for us to compile a list of, okay, what channel are we tapping into? What are the most common false positives that would come out of this? And collaborating with the community and trying to put as much effort, if not more effort, into simulating or generating training sets of these false positives and including them in the model. A multi-class classifier, I think, would be best. The downside of this is that the classification performance will decrease. You would introduce a lot of confusion, which is, I think, normal, because sometimes even a human scientist doing visual inspection, they don't know if this rice is supernova or they don't know if this rice is microlensing. We need more points. So certainly you can't blame the machine learning engine for being more confused when you introduce these classes. So it would reduce the number of true positives, which is the downside, but it will also reduce the number of false positives. But since we're going to be getting more candidates than we can possibly follow up, it's really that bad to reduce the number of true positives. If suddenly your machine learning model, maybe one day you tap into the alert stream and it outputs a positive detection with 81% probability prediction, and you say, wow, 81%, I haven't seen something this high in weeks. This is something that I want to follow up. I think I'm just afraid that the number of false positives that we're going to get is going to be higher than even our worst estimates. And I think it's because, yeah, our models are good at finding particular objects, and we just don't put enough attention into generating quality training sets and training our model with the remaining false positives. And the plastic and the elastic data challenge released by the Rubin community, I think, was a step forward to trying to tackle this, but I don't think we're quite there yet. It requires collaboration across different science teams, so different teams can simulate or they have training sets that are more specific to their science case. I mean, eventually the goal is, can we have one unified classifier that can accurately detect everything? I'm sure at some point, we're not there yet. So I think the best case is for us to pay close attention to these false positives and make sure that we include them in our training data as best as we can.
Okay. Would you like to respond, either of you?
So I don't know if any of the people related who work closely with alerts have something more wise to say than I have. So I'm not, I don't work with alerts often, but from the point of machine learning, it definitely makes sense to create more complicated surveys that are probably will give worse performance for our training models, but will be more useful in the end. So it's actually a good point. Another good point is having a data set with a lot of potential false positive cases, and then try to establish ways, maybe some additional observations that are time cheap and effort cheap, but that can be performed quickly and figure out, so discern whether this is a false positive or true positive, so that we could trigger a more elaborated follow-up quickly. I have no idea whether it makes sense, but
I just wanted to say that I think we picture Rubin turning on, but it's actually for alerts going to be a slow ramp up as we collect templates and like pre-DR1. And so I think that might we could almost think of like the year one data as a training set to prepare us for like when data release 1 drops, that's going to have templates for everything. And then we're really getting that full alert stream. But that the early days are going to be, very exploratory, I think.
Yeah, that's a great point. And I encourage people to look at, I think it's Ridgway et al. 2014, where they study the the rate of truly new things that will pop up in the alert stream. And at the start, everything's new, right? A year or two in, there are fewer things that are new. Yeah. Yeah. Any other points or questions for now? Wanted to is it just I think maybe this will come up again, but sort of the crediting big data, giving credit where it's due, large teams, high risk, high reward science. Where does an individual fit in all this? I think these are all things that are somewhat in tension, and maybe our field is still struggling a bit how to deal with giving proper credit and also motivating individuals to do the work. So yeah, maybe that's something we can discuss later.
And on a comment, and it's high pressure things. So it would be okay if we didn't depend so much on how much recognition we get for all these tiny things.
Yeah. Yeah, Nobel Prizes are still only awarded to individuals, right? So, yeah. Thanks again for the TDA and MMA summary.